Hello, everyone. You are welcome to our class. Without much waste of time, let's begin today's class. So, we are going to start from the fundamentals in mathematics. We start by knowing the types of number, which I believe most of us have already know. We have natural numbers. Your natural numbers, they are the first number we ever meet, and we call them whole number. They range from 0 to 9, which is 10 numerals. And the position of all these numerals dictate the place value it represents. For instance, if I have 249, for instance, 2, the place value of 2 here is 100, which is 200. And the place value of 4 here is 40. And the place value of 9 here is 9 units. So you remember your primary school 100, tens, and unit. Now, numerals can be represented by equally spaced points on a straight line, otherwise known as a number line. So it is all that, meaning that either in increasing order or decreasing order, as the case may be, any number to the right of 0, then it will increase in order of 1, as the case may be. So we use this number line. So, and this all, we call them natural number, or we call it a whole number. Then the next one is integer. So integer is positive and negative numbers, including 0. Integers are positive and negative number, including a 0. So in our number line, if you position here to be 0, then any number to the right of 0 will be positive, 1, 2, 3, 4, and so on. And to the left of 0, we have -1, we have -2, we have -3, we have -4. So as it is going like this, it's decreasing in order. So -1 is greater than -2, as -3 is greater than -5, and so on. So if you are going like this, 1 is greater than 0, and 2 is greater than 1, as the case may be. And take note, remember that 0 is greater than -10, right? And 0 is greater than -1, as the case may be. So that is about this one. So we should know our integer. We should also know our whole number. The difference between the whole number and integer is that integer comprises of what? Negative and positive number, including 0, while the whole number is from yours. Whole number or natural number is from 0 to what? To 9. You can have other combination of whole number. When you combine anything 0, 1, 2, 3, if you have 2, 4, 3, it's still a whole number. If you have 3, 4, it's a whole number. So we can combine it. But whenever you include 0 and negative, then it has become an integers. Other things related to numbers manipulation, like brackets. Brackets should be used around negative numbers to separate the minus sign attached to the number from arithmetic operation symbol. For instance, if in math, I cannot have 3 times, I cannot write 3 times -3. It's not written like this. The best way to write it is 3 multiplied by open bracket -3. This is the best way. Is that clear? Likewise, I cannot say 3 minus -4. The best way to write is 3 minus into bracket -4. So these are the reason we use what? Bracket. Now, addition and subtraction. Adding 2 numbers gives their sum, while subtracting 2 numbers gives their differences. Most of the time, if you have taking a bigger number from smaller number, in our primary school time, they say it's not possible, but it's very possible. That's to say it's going to give us negative number. So now, if you meet this kind of question and you don't know how to come about it, 4 minus 6, you can use number line. So your number line, you have 0, like this, become positive 1, 2, 3, 4, as the case may be. Then to the left of 0, minus 1, minus 2, and so on. So you can use number line. This is 4. Starting from 4, then you can count how many? Minus 6. You count 6 times. 1, 2, 3, 4, 5, 6. Your answer is minus 2. You don't want to go through the stress of what? Doing your number line. Okay, 4 minus 6. You are doubting your answer because this is taking big number from small number. But reverse it to be 6 minus 4, which you will quickly answer to be what? To be 2. So if 6 minus 4 is 2, therefore 4 minus 6 is equal to what? Minus 2. It's as simple as this. I hope this is clear. So we can also use number line to solve this type of small questions. The next is multiplication and division. There are some facts we need to know about multiplying two numbers, whether positive number or negative number. So like multiplying and dividing two positive number or two negative numbers gives a positive number, gives a positive value. For instance, if I have minus 3 multiplied by minus 2, it will give me 6. If I have minus 15 divided by minus 5, it will give me 3. So that is another fact. The next is multiplying or dividing a positive number by a negative number gives a negative number or negative value. If I have minus 3 multiplied by 2, it will give me minus 6. And if I have minus 20 divided by 4, gives you what? Minus 5. So these are some of the facts we need to familiarize ourselves with. The next is bracket and precedence rules. Bracket and precedence rules are used to remove any sort of ambiguity in calculation. For instance, if I have 14 minus 3 multiplied by 4, the answer could be 44. It could be what? 2. So in this case, how do we come about it? How can we know how to solve it in order for us to get the right answer? Now, remember our board mass. Board mass. The board mass simply means bracket, order, division, multiplication, addition, and subtraction. So now we are going to take cognizance of what? Division and multiplication, they go together, and addition and subtraction goes together. So when you're solving this type of thing, you start from left to right. Left to right. Where you see multiplication and division, you work from left to right without giving regard to either division first before multiplication. That was how we were told that you have to consider division before multiplication. No. As far as you see division and multiplication in the same operation or in the same problem, you just work from left to right. But whenever you see division and subtraction or division and addition, you consider division first. As you are still working from left to right, you consider division first. Also, whenever you see multiplication and subtraction or multiplication and addition, you consider multiplication first before addition or multiplication first before subtraction. But when you see multiplication, subtraction, and addition, don't give regard to anyone that comes first. Just work from left to right as the question is. Is that taken now? Now let's look at this. I have the operators I have here are minus and what? And times. In that case now, I told you I have multiplication and what? And minus. I'll give cognizance to multiplication first. So that will give me 14. Then remember this negative belongs to 3. It will be minus 3 times 4. That will give us minus what? Minus 12. Then 14 minus 12 gives us what? 2. So this is the best way to tackle this type of question. So if the other way around, you say 14 minus 3 times 4, and you now come and say 14 minus 3 gives us 11, then times 4 gives us what? 44. This is very wrong. I hope we get this one now. Then basic laws of arithmetics. We have commutative, we have associative, and we have distributive. Commutative simply says that when two integers are added or multiplied, regardless of the order of multiplication or addition, it will not affect the result. For instance, if I have 3 plus 5, it's the same thing as 5 plus 3, which is equal to 8. That is commutative. If I have 6 times 3, it's the same thing as what? 3 times 6, which is equal to 18. So this is what the law is talking about. The next is associative. The way in which 3 or more integers are associated under addition or multiplication does not affect the result as well. For instance, if I have 3 plus into bracket 2 plus 5, it's the same thing as saying 3 plus 2 into bracket 5, and it's the same thing as saying 3 plus 2 plus 5. This is what the associative law is talking about. If I have 5 times open bracket 6 times 9, it can also be written as 5 times 6 close bracket times 9, which can also be written as 5 times 6 times 9 without any, it will not affect the final result. That is what associative is talking about. So the next is distributivity rules. This one is saying that multiplication is distributed over addition and subtraction from both the left and the right. For instance, if I have 3 multiplied by into bracket 4 plus 5. So the best way to go about this is equal to 3 multiplied by 4 plus 3 multiplied by 5. That will give us 27. So this is the best way to go about it. The same goes to division. If you have, for instance, if I have 60 plus 15 all divided by 5. The best way is to say, okay, 60 divided by 5, then open bracket plus 15 divided by 5. So that's what the distributivity rules is talking about. So after doing this, let us now begin with the first topic in Jamb syllabus, which is number base. Number base is just a way of measuring numbers, just like what we have in measuring other things. We use a particular instrument. Like if you want to measure a cup of rice, we use a measuring cup. If you want to measure water, you use a measuring cylinder, and all other way of measuring the quantity of things. So to measure the number, we make use of what? Number base. So number base can be base 2, can be base 3, can be base 10. The one that we are all familiar with is base 10, which is the whole numbers, right? So now, binary numbers is a way of what? Of measuring numbers. So we can convert from one number to another, like from number in base 10 to number in base 2, or number in base 2 to number in base 10. We can also convert from one number to another number, as in from one base to another base. So, for instance, convert 23 to number in base 2. So in this case, we are going to use, sometime you'll be given as 23 in base 10, but whether they put 10 or not, just know that it's already in base 10. So you have to convert this one to number in base 2. All we are going to do is to use 2 to divide 23 repeatedly. So you do a tabular form. You put your 23 here, put your remainder here, put your 2 that you're going to use to divide repeatedly. So now, how many times can 2 goes into 23? You can say 23 divided by 2. That's what it means. So 2 in 2 gives us what? It goes by 1 times without remainder. 2 in 3, it goes by 1 times remainder 1. So it shows that 23 divided by 2 is equal to 11. So this is 11 to remainder 1. The next, you use 2 again. How many times can 2 goes into 11? It goes by 5 times, remainder 1. 2 again. How many times 2 goes into 5? It goes by 2 times, remainder 1. How many times 2 goes into 2? It goes by 1 time, remainder 0. Again, how many times does 2 go into 1? This time around, you go by 0 times, remainder 1. When you are done, you drew this line showing that you are taking your number upward. So that is 23 in base 10 is equal to what? 1, 0, 1, 1, 1 in base 2. So that's what this is all about. This is how to answer this type of question. The next is to convert 59 to a number in base 2. 59, just like what we have just said, this one is already in base 10. Even though without written base 10, if you see a number like this, you know that it is already in base 10, except they write base 2 or base 5 or so. So now we have 59 in base 10 to number in base 2, right? So we are going to use 2 to divide this repeatedly. We're going to use 2 to divide this 59 repeatedly, just like the way we do the first one. So here is 59, and here is 2, and here is the remainder. So how many times 2 goes into 59? As usual, 2, 59 divided by 2. Now use this 2 to divide 5. Use this 2 to divide 9. Now, how many times can 2 goes into 5? It goes by 2 times, because 2 times 2 is 4. Then if you say 2 times 3, it will give us 6, which is more than 5. So it remains that 1. That 1, I put it in front of 9. So it now becomes 19, right? So 2 in 19, how many times can you see 2 in 19? If you don't know, just use the multiplication table idea. 2 times 10 is 20. So 2 times 8 is what? 18. 2 times 9 is what? 18. So meaning that 2 can go into 19 by 9 times remainder 1. So we have 9 here, remainder 1. So 59 divided by 2 is 29, remainder 1. So that is 29, remainder 1. Again, how many times can 2 goes into 29? Just like what we have just done, 29 divided by 2, 2 into 1, then 2 in 9 is 4 times remainder 1. So 29 divided by 2 is 14, remainder 1. So I have 14, remainder 1. So again, 2 goes into 14. It goes by what? By 7 times. This time around, it does not remain anything. That is remainder 0. 2 go into 7 by what? By 3 times, remainder 1. Again, 2 go into 3 by 1 times, remainder 1. And 2 go into 1, 0 times, remainder 1. So now again, you take your number from upward. So I'm going to have 59. 59 in base 10 is equal to 111,011 in base 2. I hope this is clear. Then the next is binary numbers conversion from number in base 2 to number in base 10. So how do we convert from number in base 2 to number in base 10? Like this one, you have to convert 10011 in base 2 to number in base 10. In base 10. Right? So I can just quickly expand this 10011 in base 2, right? So number it from here 0, 1, 2, 3, 4. In your exam, there's no time. So anytime you see 0 like this, just jump it, please, to reduce your time. So I'm going to have 1 multiplied by 2 raised to by the power of 1, which is 4. Then plus what? Plus 1 multiplied by 2 raised to the power of 1, which is here. Then plus 1 multiplied by 2 raised to the power, which is what? 0. So I'm going to have 2 raised to the power 4. That will give us 16. 16 times 1 is what? 16. Plus 2 raised to the power 1 is 2. 2 times 1 is 2. Plus 2 raised to the power 0. Any number raised to the power 0 is equal to 1 in mathematics. So 1 times 1 is 1. So by so doing, I have 16 plus 2, that is 18. 18 plus 1, that will give us what? 19. So therefore, 10011 in base 2 is equal to 19 in base 10. So that is about this. So the next is simplify root of 1001 in base 2. So in order to do this, all you need to do is bring this and convert it to number in base 10. I have 1001 in base 2. The number in base 10, as usual, number is from 0, 1, 2, and 3. As I told you, don't stress here because it's going to give 0. Just quickly say 1 times 2 raised to power 3 plus this one, 1 times 2 raised to power 0. This will give us 2 raised to power 3 is 8. 8 times 1 is 8 plus what? 2 raised to power 0 is 0, 1 times 2 raised to power 0 is 1, 1 times 1 is 1. That will give us what? 9. This implies that root of 1001 in base 2 is equal to root of 9, which is equal to 3. I hope this is clear. Again, you have to express 101.01 in base 2 as denary. Denary is the same thing as number a decimal. So number in base 10. In base 10. So that is what denaries mean. So I'm having 101. I'll expand it from here. 0, 1 in base 2. Any number to the left of this point will be positive. So 0, 1, 2. And any number to the right of the point will be negative, which will be minus 1 and minus 2. Right? Remember our number base that we just discussed about. So I'm going to have the same way we have been doing it. I'm going to have 1 multiplied by this number, the base, raised to the power here, which is what? 2. 0 is here. I'll not stress myself there. Plus 1 times 2 raised to power 0. Plus 0 is here. I'll not stress myself. Plus this one, 1 times 2 raised to power minus 2. Is that clear? So I'm going to have here 2 times 2. 2 raised to power 2 is 4. 4 times 1, that will give us 4. Plus 2 raised to power 0 is 1. 1 times 1, that will give us 1. Plus, this is, in maths, if I have 2 raised to power minus 1, it is the same thing as 1 over 2 raised to power 1. 1 over 2 raised to power 1. Right? So in this case, 2 raised to power minus 2 will be equal to 1 all over 2 raised to power 2. So the whole of this multiplied by 1 is the same thing as this value. So I'm going to have 1 all over 2 raised to power 2, which implies I have 4 plus 1, that will give us 5. 5 plus 1 all over 4. If I do this, I have my LCM to be 4. 4 divided by 1, 4. 4 times 5, that will give us 20. 20 plus 4 divided by 4 is 1. 1 times 1 is 1. That will give us what? 21 all over 4. 21 over 4 will give us 5.25. 5.25. So the question we say we should add this together. So I might decide to take just the way we used to arrange numbers in base 10. So here I can say, okay, this is 5-digit number, and this is 4-digit number, and this is 3-digit number. I start from 5-digit number. I have 1, 0, 1, 1, 1, plus the next one is 1, 0, 1, 1, 0, 1. The last one is 1, 1, 1, all in base 2. So 1 plus 1. You should know that number in base 2, your answer is ranging from 0 to 1. Just like number of number in base 10, the answer is ranging from 0 to 9. So you cannot have anything more than 9. If it is more than 9, like 10, you are going to carry. So here too, if your answer is more than 1, then you are going to carry a lump of 2. So let's do it and see. 1 plus 1 is 2. 2 plus 1 is 3. So I'm having 3, which is more than what? More than 2. Like 1, 2, 3. The answer is more than 2. So I'll take a lump of what? 2 as 1 item. So what is remaining is 1. That is what I'm going to write as my answer. Please take note. That lump of 2 that I carry and make as 1, I'll put it here. So 1 plus 1 plus 1, 3 again. Just like that. I take a lump of 2 and the remainder, which is 1, I'll write it here. Then the lump that I carry, I'll put it here. So now I have 1 plus 1 plus this 1, this is 1, plus 1, making it 4, right? Now I have 2. I have how many 2's in this 4? That is 1, 2, 3, 4. I have a lump of 2, which is 1, another lump of 2, which is what? 1. So I'm having 2 now, and it remains nothing. It remains 0. So that is 0 I'm going to write. So the ones I carry, that is 1 plus 1 now is now 2. So I'm going to write it here. So I have 2. So 2 plus 0 is 2. 2 plus 1 is 3. So I'm going to have 3. The same thing, 1, 2, 3 I carry a lump of what? 2. So remember what? 1. I write that 1, right? Now, the 1 I carry is now here, right? So that's what I'm going to put here. Now, 1 plus 1 is 2. So answer is 2. And my answer must not be 2. So I'll carry a lump of 2. When I carry a lump of 2, I make it as 1. So it remainder what? It remainder 0. So that remainder is what I'm going to write. And the one that I carry, there's no any other addition. I'll just take it to be here. Is that taken? So that is how I get my answer to be what? 1, 0, 1, 0, 1, 1 in base 2. All these are in base 2. So if you are working in base 3, your answer will be from 0, 1, and 2. If you are working in base 4, your answer will be 0, 1, 2, and 3, and so on. So the next thing is converting from base 2 to other bases. For instance, I have 4, 2 in base 5 to number in base 3. So in this case, this is 4, 2 in base 5. So it's not in base 10 that we used to do the other way around. So since it is in another base, convert it to base 10 first. Whatever you have, you now convert it to base 3. Whenever it is in base 10 and you are converting to other base like base 3 or base 2, you use that 3 to divide all through. Okay. Now this one implies I'm converting this 4, 2 in base 5. Here is going to be 0. Here is going to be 1. This will be equal to 4 multiplied by 5 raised to power 1 plus 2 multiplied by 5 raised to power 0. That will give us 5 raised to power 1 is 5. 5 times 4 gives us what? 20 plus 5 raised to power 0 is 1. 1 times 2 gives us what? 2. This is going to be 22 in base 10 now. Now, to convert this thing to base 3, we use 3 to divide 22 repeatedly. So I have 22. So I have my remainder. I have my 3. We are converting to base 3. So how many times can 3 goes into 22? It goes by 7 times because 3 times 7 is 21. Remainder 1. So how many times can 3 goes into 7? It goes by 2 times. Remainder 1. How many times can 3 goes into 2? It cannot go. So that will be 2 times remainder 0. So the answer, no. That will be 0 remainder 2. Sorry. 0 remainder 2. So the answer will be 2, 1, 1 in base 3. So therefore, 42 in base 5 is equal to 2, 1, 1 in base 3. The next one said, if M5 in base 10 is equal to 100, 1011 in base 2, find the value of M. This shows that M is a missing number here in base 10. So for us to equalize it, you have to convert this one in base 10, convert this one to base 10. So how do we do that? We have been doing it. You have 1, 0, 0, 1, 0, 1, 1 in base 2 is equal to, you number from here, 0, 1, 2, 3, 4, 5, 6. I said, don't consider zeros. So I'm going to start from here. 1 multiplied by 2 raised to power 6. 1 multiplied by 2 raised to power 6 plus the next one here I'm going to consider is 1. 1 multiplied by 2 raised to power 3 plus, I'll not consider 0 again. 1 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. So 2 raised to power 6 is 2 times 2, that is 64. 2 times 2 times 2 times 2 times 2 times 2. So here is 8. 8 times 8 is what? 64. So I have 64 times 1. That will give us 64. Then plus 2 raised to power 3 is 8. 8 times 1 is 8. Plus 2 raised to power 1 is 2. 2 times 2 is 2. Plus 2 raised to power 0 is 1. 1 times 1 is 1. So this will give us 74, then 75. So the answer is 75 in base 10. It shows that we have M5 in base 10 is equal to 75 in base 10. It simply means that M is equal to 7. Are we clear? So the next is find N if 34 in base N equal to 10011 in base 2. So as usual, if you have something like this is 34 in base N equal to 10011 in base 2. So convert this to base 2 as well. Convert this to base 10, convert this one to base 10 as well, right? So number from here, 0, 1, also here, 0, 1, 2, 3, 4. So I have 3 times n raised to power 1 plus 4 times n raised to power 0 is equal to, I told you don't have time in your Jamb, so consider this one, just omit it, because at the end it's going to give you 0. So I have 1 times 2 raised to power 4 plus what? Plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. So n raised to power 1 is n. I have 3 times n, gives us 3n, plus n raised to power 0 is 1. 1 times 4 gives us 4. This one will be equal to 2 raised to power 4 is 16. 16 times 1 is 16. Plus again, 2 raised to power 1 is 2. 2 times 1 is 2. Plus 2 raised to power 0 is 1. 1 times 1 is 1. So this will give us 3n plus 4 is equal to 19, right? So that shows that 3n is equal to 19 minus 4, which implies 3n is equal to 15, right? Then divide both sides by 3. So 3 cancel 3. This implies n is equal to 5. So are we together? So this one also, I ask people to do this one as a class activity. Please ensure you do it and submit.